Hi class, this video is going to help with 4.5, which is the inverse of a square matrix. Okay, so this section we're really just doing the inverse. How do we get it? And then we're going to learn how to use it to help solve systems of equations. All right, so the first thing, what is an inverse? Okay, you cannot find the inverse of a matrix that's not square. So some of your homework will just say, can you find the matrix of this? It has to be a square matrix, okay? So the other thing is, you can use this augmented form with the identity matrix to get your inverse. So this is one method that we will use, and then we have another method for a 2x2. So anyway, this method is using augmented matrices. It also is the way your calculator will do it, so it's great. An identity for a 2x2 is right here. The identity is just the ones down the diagonal and zeros. The identity for the 3x3 is going to have the ones down the diagonal with the zeros. Okay, so that's what the identity is. I think we've learned that, but honestly, I can't remember. So what we're going to do is we're going to set up our original matrix, whatever the square matrix is, 2x2, 3x3. Then we're going to do the identity over here, and we're going to do row operations until we transform this with the identity on the left side and a new matrix on the right. And the new matrix on the right is going to be our inverse. We could also use this notation of a -1 exponent. That is the notation for inverse. So just like when you did inverse matrices, not matrices, inverse of functions in algebra, that was the same kind of notation. Okay, might be what your calculator has as well, is that -1 notation. All right, so that's our first method. So let me do one with that method that's smaller than that one. All right, did I have one over here? Nope, just gonna do one. Okay, so here's example number 1. Okay, and if we have the matrix -6 to 14, -4. Okay, and this one has fraction answers, which is common, it's fine. So if I want to use this method I just learned, what am I going to do? Well, I am going to take and put what we have down. So we were going to have -6 to 14, -4, a line, and then we'll do the identity matrix for the 2x2 like this. And then we're going to do row operations, just like we did in the last section. We want a 0 here first. So if I times this row by 3, then I would have a 6, and -6. So it'd go to 0. So I'm going to take and times 3 by row 2. Then I'm going to add it to row 1 and replace it on row 2. So again, we're only changing one row. We're going to times by the bottom row, add them together. That becomes the new bottom row. I think I can fit it over here. We'll see. All right, so am I going to change the top row? I am not. So we'll keep that all the same, just like that. And then we're going to go 3 times 2 is 6. I'll just do it real small right here. 6 plus -6 is going to give me the 0. That's what I wanted, but I have to do the whole row. 3 times -4 is -12. Okay, so we'd have a -12, and the 14 would leave me a 2. Okay, 0 times 3 is 0. 0 plus 1 is 1. 1 times 3 is 3. 3 plus 0 is 3. So you can start to see the transformation on the right side here. Okay, they're not going to stay the identity. All right, so from here, we have our first 0. Now we want this one here. So if I times this row by -7, then I could add and get that to be -14, and that would add with the 14. So we're going to take -7 times row 2 plus row 1, and this time where are we going to replace it? On row 1. We already changed row 2. All right, and we'll worry about this being a 1 last. We get our zeros, and then we worry about that part. So let's do that step. So -7 times 0 is 0. 0 plus -6 is going to give me -6. 2 times -7 is -14, plus 14 is 0. -7 times 1 plus 1 is -6. 3 times -7 is what? -21, plus 0 is -21. And the second row, we kept the same. There we go. All right, now we almost have our identity on the left side, but we have our zeros. That's our starting point. Now I want these to be 1s, so what can I do? I can divide by -6, and I can divide by 2. So here's where our fractions are going to come in. So we're going to take row 1 and divide it by -6, and we're going to take row 2 and divide it by 2. All right, so this top row is going to become 1, 0, 1, -21.6. It's 21.6, but does that reduce? Yeah, 3 goes in. Hello, 7 halves. Okay, because this is what it would have been, and then that will reduce to 7 halves. I was just trying to reduce the fraction. I wrote it down. Okay, bottom row. Okay, 0 divided by anything is 0. 2 divided by 2 is 1. 1 divided by 2 is 1/2. 3 divided by 2 is 3 halves. Done. Okay, finally got it done. What's my inverse? So matrix's inverse is going to equal 1, 7 halves, 1/2, 3 halves. Yay! Ta-da! Oops. Ta-da! All right. Let's then show that method. No, maybe I'll show the calculator in just a second. So let's show the kind of shortcut determinant method with the 2x2. So this method, maybe I'll show you my notes just because it's written out pretty. All right, couple more things I'd like you to add to your notes so you can pause and write this down. I don't know what the blob over here is, I apologize. But if you find a row of zeros to the left, right? So the row of zeros on the left at all, then you don't get the identity on that left side. What you will do then is it'll have no inverse, which is totally possible. All right, so the inverse can be found by using something called our determinant. Okay, so our determinant is pretty easy to get. If we have a 2x2, now I'm only going to use the determinant method for a 2x2. You can look it up for a 3x3, or if you've learned it before, you're more than welcome. It's a little bit more complicated, and I'm just going to stick with this method for only a 2x2. Okay, so what can we do to get the determinant? We do A times D minus B times C is going to give me my determinant. So once I find my determinant, I can use it with my inverse. The way I use it with my inverse is here's my original. I am going to take, and if that's our just saying inverse, I'm going to take that 1 over determinant, or basically I'm going to divide by the number. But notice what I did here. I have to switch these two, switch, and change the signs of these. I know, totally tricky. Write that down, pause the video. Do note the determinant cannot be 0, because then I'd be dividing by 0. Can't have that. So what do? I find this number, the determinant, it's pretty easy to get, and I'm going to switch around the numbers, change some negatives, and then I can multiply by that 1 over D or divide by D and get my inverse. One other thing is how to tell if something is an inverse. So is this one, however way I want to say, is this the inverse of this? And the way that you do that is you do your matrix multiplication and get back out the identity. Okay, so division and multiplication undo each other. So the idea is I can undo it and I better get the identity. So remember, for matrix multiplication, I'm going to do row times column, add them together, and I better get a 1. Row times column, add them together, I better get a 0, and so forth. This one does not work out. Watch why. -5 times -3 is going to give me positive 15. And then 3 times 4 is 12. When I add those together, just for this one times this one, that's not a 1. So it's already a no. So if you were asked in your homework or on your test, are these two inverses? There's a quick way to do it, just your matrix multiplication. Okay, let's do the same problem we just did, but with our new method. So we have, this is our, same problem really, new method. So I have these numbers here. And again, I want to find the inverse. All right, so let's use our determinant method. So the determinant says this one times this one. So -6 times -4. And then you're going to take that answer and subtract off 14 times 2. All right, well, that's going to be what? 24 minus 28. So I get -4. Right? -4. So that's our determinant. What was our next step to get this inverse? Our next step was to flip these two and change the signs of these two. So signs, flip. So we're going to do that real quick. This one becomes -4. This one becomes -6. And this one will now become -14 and -2. Okay, and then 1 over -4. We're going to times everything or by 1/4 or -1/4 or divide by -4. So times these, what are you going to get? 1. 1. Well, -4 over -14 would reduce to a positive 7/2. Okay, this one, -4 over, other way, -2 over -4, right? Because this becomes your numerator, is going to be positive 1/2. And -6 over -4 is going to become positive 3/2. I wrote that fraction different than the other two. Sorry. So we call this our inverse. Done. Isn't that the same answer we got on the last one? I sure hope so. Whoop. Yes. Right? All positive? Yep. So same answer. I love this method. That's why I'm showing it, and the book shows it in your examples and stuff like that. This method is fabulous if you have a 2x2. It's quick. You get this number quick, switch, change your signs. It's just kind of hard to remember the steps. But hey, your class is online, or you're allowed a little note card for mine if it's in person. Either way. Okay, you could write it down and bring it with you. All right. Couple tricky ones real quick. What if I just had a 1 by 1? What's the inverse of a 1 by 1 matrix? Oh, that's kind of tricky. So the inverse is going to be 1/9. Done. Just flip it over for your fraction. If it's 9 over 1, it's going to become 1 over 9. Kind of a tricky one. Here's another sort of trick question. What is the inverse of this one? All right, we have a row of zeros. Done. No inverse. doesn't exist. Or you could get that determinant, and that's going to say 0 times 0 minus 3 times 0, which is 0 minus 0 or 0. So it doesn't exist. So no inverse. Not possible. Okay. Last kind of tricky one here. What if I have 1, 2, 3, 4, 5, 6? I'm lazy. What if that's my matrix? What's the inverse? Can't do it. Not square. It doesn't work. Like I can't get the identity. There's not an identity for something that's not square. So no inverse on this one either. Okay. So those are my tricky ones. Last but not least, I think what I'll do is just kind of walk through this one, and then I'm going to show on your calculator. Ooh, I'm bringing out the ugly one. So here's my matrix, right? Now it's a 3 by 3. I don't have a row of zeros. I'm going to have to find the inverse of this. And I don't have a shortcut with the determinant that I taught you because it's a lot trickier. So we have to use our method of setting this up with our identity on the right, okay? And then using row operations. So here's our identity. Now we need to do row operations. What's cool is this one already has some zeros. So it isn't that many steps. So we have a 0 here. Where's the next 0? Remember how we learned it? 0, 0, 0, 0, 0, 0. We go in that order, or you're gonna get frustrated and lose zeros and things. So we want to get a 0 here. So what I did is I took -2 times row 1. That would be that would put a -2 here. Add that to row 2, and then put that back on row 2. So here we are. So ignore this part for a second. Here's where we're at. We took -2 times 1 plus this one, and -2 times row 1 plus row 2. And then we're replacing this on row 2. So -2 plus the 2 is the 0. -2 times 0 plus the 1. Did I do -2 times this 0, duh, plus -2 times 0 is 0. I did it backward. Plus the 1 is a 1. -2 times 1 is -2 plus 0 is -2. Yep, you lost a 0. There's nothing you could do about it. You have to get these in this row first. And then you finish off, okay? So you do that process all the way through. So -2 times this one plus this one. -2 times this one plus this one. -2 times this one plus this one. And then row 1, row 3, we didn't change. We only changed one row per problem, or per, we only changed one row at a time. Okay, so where should we do our next 0? Our next 0 is here. Well, we're really close. We want to use these so that when we add the zeros, we keep the zeros. So we don't want to use this one, or we become a 1 here or there. So we don't want that. So here, if one of those was negative, we could add. So we're basically going to subtract our rows, or basically you're timesing by a negative on the row 3 and adding them. So we're going to subtract our rows, and that's going to get us here. We did row 2 minus row 3. 0 minus 0 is 0. 1 minus 1 was 0. -2 minus a -1 is a -1. -2 minus 0 is a -2. 1 minus 0 is a 1. 0 minus 1 is a -1. If you have to write, I had it down too far, apologize. If you have to write that out, do. But again, what did I do? This one minus this one is this one. This one minus this one was this one, and so forth. They figure I had it too low. Now we have 0, 0, 0, and look, woo, another 0. You'll find I'll do that on the test too, like, so you can go quicker. You'll have some that just already have some zeros for you. Okay, so we need to go here, then here. If I get this 0, I need to use row 1 and row 3. See how I use those? because 0 plus 0, we keep this 0. Okay, so we can basically just add row 1 and row 3 because they're already a 1 and negative 1. And that will replace on row 1. So 1 and 0 made 1. 0 and 0 made 0. 1 and negative 1 made 0. 1 and negative 2 made negative 1. 0 and 1 made 1. 0 and negative 1 made negative 1. Everything else stayed the same. Okay, now I just need to get this one. So I did negative 2 times this row plus this row. Let's ignore this yet, but so we're going to take negative 2 times row 3 and negative 2 times row 3 and then add it to row 2 and replace it on row 2. So negative 2 times row 3, negative 2 plus the 0, that's going to give me a 0. Negative 2 plus the 1 still gives me a 1 because 0 times negative 2, 0. Negative 1 times negative 2 is going to be positive 2. 2 plus negative 2 is 0. And then you just keep going. You got that part. I'm not too worried. Then I changed the bottom row by already timesing it by negative 1. I was getting a little lazy. But what is our inverse going to be? Because I need the 1, 1, 1. And basically they were all ones except this was negative. So I had to change all these signs and by timesing by negative 1, and then I'm at my inverse. So here's the inverse. Okay. So because we need to use these, we do want to use technology. Hopefully this is going to come through clear. We're here. So on the TIs, 83, whatever ones, there's a matrix button. I'm going to click that. This first one is just our names. That isn't what we're going to use right away. What we're going to go over to is edit. And I'm going to push enter. And I would like this to be a 3 by 6. Okay, enter. And what I'm going to do is I'm going to put in my original setup. That is going to be original times your identity. So this top row is going to go 1, enter, 0, enter, 1, enter, 1, 0, 0. The next row needs to go 2, 1, 0, 0, 1, 0. The bottom row needs to go 0, 1. Always use the negative by the enter when you go to put in a negative. This one, or you'll get an error and you'll get frustrated. Negative 1, 0, 0, 1. Double check you put it in right. Okay. Then I'm going to hit matrix and I'm going to do math. Here's where we can find the determinant. That's the first one. The T, I can't remember if we learned about that or not. Anyway, we're going to go down till it's in reduced row echelon form. That's why the crazy name's important, because technology says RREF, reduced row echelon form. That's what we want. Okay, so we're going to hit enter on that. Oh, wait, my calculator's weird. I have to clear out of everything. Apologize. Matrix, and then go to math, then go down to reduced row echelon form. It's way at the bottom. Hit enter. Now I'm in the calculate area. So I'm going to go back to matrix. I'm going to call up the name A. That's what that first one's for. And then end my parenthesis and hit enter. And it does it for you. Okay, so I kind of have to scroll over. And then should be the same answer we got here. So negative 1, 1, negative 1, 2, negative 1, 2, 2, negative 1, 1. Yay! Calculator did it for us. Now, so what did we do again? We hit matrix, right? We go to edit. In edit, we put our information in. So it'll become either a 2 by 4 or a 3 by 6 with our identity on the right. Then I get out of everything, back to the calculator mode where I could put in numbers. I just turned it off. Back to calculator mode. Then I hit matrix again. and I go to math and tell it reduced row echelon form. And then I can do the name and stuff. Now, if you have a newer calculator, you might be able to put in your matrix and call it up like matrix A, maybe C has one that's a 3 by 3, and then say to the -1, and it gives you the inverse. Mine won't. So you might be able to put your original to the -1, and it says, oh, let me find that inverse for you. Most of you will have to put it in and then do the reduced row echelon form. Okay, so I'm going to minimize my thing real quick. I am going to go to, wait, no, it's Desmos Matrix. I'm pretty sure Desmos will do this for you too. Desmos Matrix calculator. It's in beta mode, which means they are still working on it. See, beta. All right, so I think I can put in a new matrix, and we would like a 3 by 3 add. And then I'm going to put in our original here, 1 tab, 0 tab, 1, 2, 1, 0. This is in case you don't have a graphing calculator. I think by now most of you have one, especially if you have to take business calc, you're going to want one. Okay, so there I am. What I did was I said matrix A is this. Okay, enter. That's matrix A. Then what I could say is I would like to take matrix A and do the inverse. And look, doesn't that match my inverse? Voila, it does. All right, should you know how to do this by hand? Oh yeah. Being able to do row operations will be on the exam, and you will have to show me each step showing me your work. So doing this the long way, like I just showed you, is important. But my goodness, if we're doing 10 problems, there's no way you could do that uses an inverse. It's too, we want to use technology. So what am I saying? Do it by hand and by technology for this homework. After this homework, for the rest of this chapter, you'll be able to use the calculator. All right, hopefully that video was helpful. All right. And again, there's more videos from the book as well if you need more.